So it is really my distinct pleasure and honor to introduce Tim here. So I've known Tim for a while now. Tim has been a mentor, a friend, my teacher. So I mean, we have a long history together. So Tim is going to talk about a new project that they have started. I will let Tim go over that when he starts. So I was trying to actually think about what's the right way to introduce Tim. I mean, industry veteran, a seasoned technology leader. I said, I mean, all of these are understatements, right? If you go and check out, Tim's profile, I mean, anything that I say, it's going to be an understatement. So just to give you an idea, Tim was the first president for Oracle On Demand, long time ago, when cloud computing was, I don't even know, I mean, if mainstream people understood what cloud computing is. At least I did not know what cloud computing is back then. And he also teaches cloud computing at Stanford. And that's how we met, by the way. I attended his class, one of the best classes I've attended throughout my time at Stanford. Then Tim is also an advisor to multiple startups. He is a board member for Teradata, Blackbaud. So there's a long list. I can spend a lot of time, but I will just hand it over to Tim. And Tim is going to get started with today's talk. And then Tim, over to you.
Hey, thank you, Raja. Let me first say, one of the great privileges of being a teacher is you get to see what your students end up doing. And I've been very proud of what you've been able to do since you've left Stanford. So congratulations on Data Science Dojo. So I'm going to share screen. Good morning or good evening to all of you. I'm going to talk about an ambitious project that basically I came out of retirement to go do, called the Pediatric Moonshot, and really cover like, why did this happen? What is our motivation? Talk about, we use the moonshot as a phrase. So, getting to the real moon required a new rocket. We believe that's true for achieving the objectives of the Pediatric Moonshot. And in that, I will talk to you about a decentralized, in the building edge cloud service that we have built a startup around called BevelCloud. It is an infrastructure. So at the end of the day, you have to answer, well, what are you going to do with it? So I'm going to show you a couple of examples on the clinical front of real-time privacy-preserving edge cloud applications. And I'm going to show you some of the work we're doing in the research side, particularly focused, obviously, on AI in medicine. And I'll probably say ChatGPT at least once during this seminar. So that's what we're going to try to do today. And obviously, as Raja said, we'll take questions from all of you. As Raja said, I basically was the first president of Oracle's cloud computing business. When I retired from Oracle, I actually started the first class on cloud computing at Stanford, which is the reason that I know Raja, but it's also the reason that this whole initiative started. So about 5 years ago, a student shows up who says, oh, I'd like to meet you. And I said, okay, fine. So we decided to have breakfast down at Joni's Cafe on California Avenue, for those of you who know the area. He walks in, I'm looking at him thinking, doesn't look like a regular student. Turns out he has an MD, an MPH, an MBA, and he's chief of pediatric cardiology at the Children's Hospital of Orange County. So I'm looking at him going, why are you talking to me? I don't know anything about what you know about. And he says, well, actually, I'm in and I've enrolled to get a master's degree in bioinformatics at Stanford because I believe that AI and big data and cloud computing need to meet medicine. So for those of you who do not know, Dr. Anthony Chang, since graduating, has gone on to be a major force in the movement to using AI in medicine, started up a conference called AI Med, published a book last year on intelligence-based medicine. And so I encourage you, if you're interested in this area, please look him up and look up the work that he's doing. Anthony is really my portal into their world, meaning the world of pediatric medicine, which is really kind of serves as, well, why are we interested, or why did I get interested in this? So very early on, Anthony told me a story of a little girl in Myanmar that he was providing consulting for. They actually wanted to share the echo, the ultrasound with him. They couldn't do it. Ended up, this little girl died on the operating room table. Several months later, he actually got to see the ultrasound, and he said, well, I could have told them what to do. And for those of you who've been in this area, you'd be amazed. They're still using CD-ROMs or the more advanced USB stick to transfer data around. But if you go deeper, you start to understand, and this really is, post-pandemic, that pediatric clinical expertise is increasingly geographically concentrated into the specialized children's hospitals in the United States and frankly around the world. If you go into the details of this, you also start to realize that not only is it geographically concentrated in the NFL cities, but it's also fairly scarce. So the number of pediatric cardiologists in the United States is about 3,000. We graduate only about 100 pediatric cardiologists a year, and yet our population grows by about 4 million kids per year. If you drop into emergency medicine, the US has only 2,403 pediatric emergency physicians, and there are none in Montana, South Dakota, Wyoming. And by the way, if you leave the US, the challenges are order of magnitude greater. In Ontario, which Sick Kids in Toronto is probably one of the leading children's hospitals in the world. So if you happen to be in Toronto, life's pretty good, but go out to Thunder Bay and there's none. Congenital heart disease is still the second most common cause of death in kids under 5 in Mexico. India has only 300 pediatric cardiologists. And if you go to Rwanda, there is 1 pediatric cardiologist in the country. And finally, there are long tail conditions that are difficult to diagnose by any one expert clinician. This is a condition called focal cortical dysplasia. It is a condition which, if undiagnosed, leads to epileptic fits. There's a little boy in Florida right now who, for the past 12 years, every day/night, he has 2 to 3 seizures. At night, he wakes up screaming. You can imagine the implications on his siblings, his parents, et cetera. Now, focal cortical dysplasia, you're actually seeing an MRI image on the left-hand side there, is a brain lesion that if you can diagnose it, you can actually resect/surgically remove it, and the kid's cured for life. So this is a great example where it's like no one clinician sees enough of this. Frankly, if we had all the MRI images of all the kids, there's plenty of, and perhaps some in the audience, who know how to build deep learning algorithms that would allow us to detect this sort of condition. Which leads us to kind of where we are today. AI applications might be the answer, meaning, can I take cardiology, neurology, orthopedic expertise, and now enable computers to be able to do this where there are no doctors? This isn't about replacing a doctor, there isn't anybody. Or in detecting and diagnosing more complex, low frequency issues. But unfortunately, and this is actually a symposium that is run by Stanford's AI and Medicine program, most AI algorithms are fairly brittle because they can't get to enough data. No one hospital, and this is particularly true in pediatric medicine, has enough data to build accurate, non-biased AI. So all of this led me, I was sitting there thinking about all this and went, this is all fundamentally the same problem. And so roughly during the pandemic, because a group of us were tired of watching Netflix, we said, well, let's go do something useful. And so we set ourselves a mission to create privacy-preserving, real-time AI, non-AI, as you will see, applications based on access to data from all million healthcare machines in all 500 children's hospitals in the world. So that's the mission. And so just for a second, let's say, well, yes, I want to go build AI algorithms. And I know Raj had asked me, there's a series of posts that I did in Medium. And so I do a whole post on why AI in children's medicine. And you guys want to take a look at it, please do. Now let's get to the next step, which is we've all seen that, well, there's been tremendous advances in AI over the past 10 years. And fundamentally, it's all been due to the fact that neural networks, which have been around technologically since the 90s, suddenly have access to enormous amounts of data and enormous amounts of compute, which, as many of you may have seen this chart from Jeff Dean, who's head of Google Brain, neural networks are the mechanism or all the underlying technology that allows us to get increasing degrees of accuracy if we have increasing amounts of data. And so for those of you who live in the Bay Area and probably any of the major metros, you still see a bunch of Waymo cars driving around, gathering more and more and more data to enable them to be more and more accurate. Okay, so the technique that we have used so far has really been, and those of your students of ImageNet know this, is let's go aggregate a bunch of data in a central site. Well, hey, let's go try that in medicine. Well, we haven't been very successful. This is actually from Kurt Langos, who runs the AMY program at Stanford. Data for AI training in adult medicine, I'm not talking about pediatric medicine, really only comes from about 3 states, New York, Massachusetts, and California. And you can bet it does not come from upstate New York or rural California. If you zoom out on a planet-wide basis, the US and China are the 2 major suppliers of data, and you see a smattering of other countries there. Obviously, none in Africa, none in Latin America, none in the Middle East, right, are sources of this data. So why is that? And I'm going to conjecture that the centralized architecture, which has worked dramatically, good for what we've seen in ChatGPT or in, being able advances in autonomous driving, et cetera, are not going to be the solution for doing this in medicine. And I'm going to give you 3 fundamental reasons. First of all, let's think about the challenge. So the Echo Lab, which is what the cardiologists use in the children's hospitals, by the way, there are about 500 in the world, and you saw that earlier. We've done a back of the envelope analysis. The data they generate, the ultrasound data they generate, is about 6 million terabytes of data per year. Just to give you a sense of scale, the NIH has an imaging data commons project where they've been trying to aggregate data centrally. They've only been able to aggregate over maybe 4 years, 60 terabytes, like 6 million versus 60. So it's plenty of data out there, right, that could be able to diagnose in a non-biased, accurate way, plenty of conditions in cardiology. So let's play the centralized architecture game. Okay, let's pick a place to put it. I have a data center in Ireland. I'm going to put it in Ireland. Okay, 6 million terabytes, a little bit much, but fine. Okay, first of all, who's going to pay for the network traffic to come from Bambino Gesù, which is in the Vatican, from Gertrude's Children's in Kenya, from Lurie's Children's in Chicago? And if I want to get the data back out, who's going to pay for that network bandwidth? So it's not really network preserving. Clearly, it's not real time to be able to have to go all the way to Ireland to go do this. And lastly, and probably most importantly, it is not privacy preserving. One of our key members of the core team is a former student who has 14 years of privacy law experience. And one of the fundamentals of privacy is purpose limitation. So when you aggregate a bunch of data, put it in some central repository, and you go, well, I'm going to do good things with it, that is not privacy preservation. So we believe that real-time privacy-preserving applications require a highly decentralized, and I'm going to make a point of this, in the building infrastructure, something we are going to call an edge cloud. Why does it have to be in the building? Now, if you think about it, the ultrasound, I'm just going to pick on ultrasound, but the gene sequencer, the blood analyzer, et cetera, that are sources of all this data are in the building, in the hospital, in the clinic. They're in the building. So the only way I'm going to be able to talk to them, to be able to get the data from them, is to also be in the building and on the network. So as I said, this caused us to build an entirely new architecture, a decentralized one. And I already kind of telegraphed what sits at the core of it. So much like EC2 and S3, we have an edge compute and storage service that enables us to run a series of applications. That's pretty simple to think about. The innovations are really in the area of how do you secure it. So remember, these are in a building. They're not in a data center where I can lock the door. So there have to be innovations in how you protect compute and storage in an environment where you cannot guarantee physical security. The other innovation has to be, well, how do you securely live on the network? So unlike the AWS model where you own the entire network in the building, remember I said we have to coexist in the network in the building to be able to talk to the ultrasound or the X-ray machine or the blood analyzer. So edge networking services are a series of innovations in how that can happen in a secure and managed way. Now, onto that infrastructure, we've developed a unique kind of application. We call this a digital twin. It is a digital twin of the healthcare machine. And so when I use the word digital twin, what do I mean? I mean that we replicate the data in the machine. What data? The static data, what's the serial number? The environmental data, what's the location of the machine? The dynamic data, what's the last error code, or what's the laser power level of the gene sequencer? And finally, what we call the gnomic data, the actual echo or the X-ray or the CT or the genome sequence. These are made available through Edge Data Services. Edge Data Services serves a number of different purposes. One, it controls access to the applications in a very fine-grained way. So much like on your phone, you get to say Twitter gets to see my photos, but not my location, and Facebook gets to see my location, but not my photos. Edge Data Services controls on a by machine basis which application, the red one, the green one, the blue one, gets access. So this is very fine-grained access data sharing. The second thing, obviously, is it standardizes the data. So now whether the Philips ultrasound is running in Rwanda or running in Redwood City, the data provided to the application is identical. And the last is we've enhanced Edge Data Services to also be able to do de-identification at the edge, anonymization or sanitization. Fairly simple to do for the structured data, we'll call it that. But the innovation with a company called Glendor is really to be able to redact it out of burned in image. So Edge Data Services supplies all of this to applications. So BevelCloud is an infrastructure which is designed to allow application developers to build applications in, and I will show you some examples of this, in cardiology or emergency medicine or radiology using this data. So for the non-technical people, so I obviously spend time talking to the clinical community, I say, well, the best analogy is really what Apple has done for consumer applications. So Apple standardized the infrastructure, the operating environment, and invited, thousands upon thousands of developers to build applications that all of you have seen on your phone. just to think about the analogy, what did Apple do? They gave you access to the GPS. They gave you access to the camera. Well, in some way, yes, we're giving you access to GPS. Well, where's the machine? And the camera in this case is an ultrasound or an X-ray or a MRI. So we designed this to be ultra scalable from very large installations, which may have 10,000 machines in it, down to small clinics. It's architected at the million server level. And as you might guess, we started this during the pandemic. We couldn't fly people to Rome to install anything. So we had to come up with a way to go do this. Obviously, it's plays into scalability to be able to install these in what we have called less time than it takes to put in a Nest thermostat. Actually, we just did an installation in Delaware where we did it in 15 minutes. So we're getting close to our objectives of a very high-speed install. So the Pediatric Moonshot at this point is really both the infrastructure in order to allow these applications to gain access to the data and the applications themselves. Just to give you a quick idea, as an engineering team, we didn't want to live in PowerPoint too long. So actually, at this point in time, we have deployed edge zones in 8 sites in the world on 3 continents. So we've moved well beyond PowerPoint into actual implementation of this. So let me now switch from infrastructure over to applications. And like I said, these are just a couple of examples of what you might end up doing with this infrastructure. So I'm going to start on the clinical side. Remember, I told you a story about image sharing. Well, last year, at the end of last year, we actually did image sharing in real time from Children's Hospital of Orange County, shared with clinicians in the Vatican in Rome at Bambino Gesù, using technology from an ISV called Teleray to go do this. So I'm just going to show you a screenshot and also introduce you. So the guy with his finger thumbs up, that's Anthony Chang. Anthony has brought his daughter Emma into the echo lab. She actually has a complex congenital heart problem. That's Dr. Wyman Lai with his back to you, who is head of cardiology. He imaged her, and that's her ultrasound image, 6,000 miles away in real time. Her godmother actually got to see, who is a pediatric cardiologist, her heart. There's a YouTube link up there, and you can take a look at this. We did a little 5-minute video to give people a sense of this, I'll say, very historic event. So how can we bring this technology, which we demonstrated, into practical applications? Well, here's one. As I said at the beginning, pediatric cardiology, pediatric medicine expertise is increasingly geographically centralized, in this case, in Orange County at the Children's Hospital of Orange County. So Mission Health or UCI or Anaheim Regional does not have that expertise. So when they want a second opinion on a kid's heart, they reach out to Dr. Wyman Lai at Children's of Orange County. The mechanism they use today, I will not go into. It's fairly primitive. Although Anthony said, well, we used to drive to each of these hospitals. So, okay, better than that. So we are working with them to build a cardiology expert network for second opinions. There's another application of the very same idea in the world of emergency medicine. It turns out that in emergency medicine, there are many cases. At this point, you'll see this in a minute. We've been spending time with the team at Pediatric Pandemic Network, which is a health and human services initiative that was launched post the pandemic, but with the fundamental thought that this of a hub and spoke model, where the hubs would be the children's hospitals. And so by virtue of that, we've ended up talking to a bunch of emergency medicine clinicians, and we hear the same story over and over again, which is the kid arrives that need to be there or has been misdiagnosed, all because the images never arrived, which we're like, you're kidding me. That can't possibly be. And so we are co-developing with our friends at Teleray, and we're actually headed to doing a meeting with the trauma directors in all these, what we call spoke hospitals in Northern California, because the UCSF team has been very articulate in what exactly the problem is here. Obviously our dream is to scale this nationally and in essence implement this hub and spoke model all across the US in a pediatric pandemic network that is operational. So I know many of you are here because you want to talk about AI, so let's just make a point of it. If you can share with a clinical expert, you can also share with an AI expert, and just to make a point of it, in the building so the data never leaves the building. So let's talk now about the research applications. How can we develop AI applications in all these areas? Well, deploying a real-time AI application to the point of care, given you understand our architecture, is fairly simple. Just to make a point of it, we actually twinned a portable ultrasound from Philips called Illumify. So you can actually think about, I can deploy all the way to a clinic and frankly, all the way into the home, all fairly simple in this model on a global basis. But the challenge really is, well, how do I train while preserving privacy? And as I said early on, the centralized model has lots of challenges if we're going to go down that path. But instead, and many of you may know this, our friends on the consumer side have been actually working on this problem of how do I train while preserving privacy and network. So Siri on your iPhone, Apple wants to make that more and more accurate. Well, it could have done it the old-fashioned way, meaning let's go take the data, we'll aggregate it up in the Apple cloud, we'll split it into test and data set, test and production, whatever, and do all what we've learned how to do. Now, the problem with that obviously is, well, what about privacy? What else did Raja say when he was talking to Siri? And the second problem is, well, it's going to chew up network bandwidth to send that audio up there. So federated learning, which also underpins Google Keyboard, and we've spent time with the Google Keyboard guys, has really been developed largely to solve this problem of how do I preserve privacy and network for consumer applications. We have done early work that says we can do the same thing in AI in medicine applications. So in this case, the data is never leaving the third floor at Lurie's Children's, or the second floor at the Children's of Orange County, or the first floor at Bambino Gesù in Rome. Each image can be learned on, and the only thing that's transmitted is a bunch of neural network weights to an aggregation server. And as it composes or aggregates a more accurate model, obviously the model can be updated as it happens on your phone as well. So as those of you who in AI know this, trying to build AI applications without data is like trying to build enterprise applications without a programming language. So we are in process to build the world's first federated learning lab, frankly, for any medicine, but obviously focused on children's medicine. We're going to deploy 100 servers, twin to 100 ultrasounds with access to uncompressed data on 6 sites in 2 continents, governed under a multi-site, multi-country IRB. And we're also going to provide an open source neural network model to measure something called ejection fraction. And our friends at Dyad Medical are championing that. And Charitha Reddy is working the IRB with, and she's a pediatric cardiologist at Stanford Children's. We want to make all of this available in a standardized way so that we can both learn about, well, which stacks work the best. So there are many stacks out there from startups as well as established providers. NVIDIA, Intel, et cetera, have been doing work in this area. HP with swarm learning. So which of these stacks work the best? as well as what strategies would work the best. Obviously, in this environment, we can do zone level aggregation, which is not possible in the consumer world. There's work at MIT in something called split learning, which could be tested in this environment. Why is this so valuable? Well, in the world of AI in medicine, and this is true in children's medicine and adult medicine, there's plenty of examples of research work that have occurred out there. This is actually research work which a husband-wife team at UCL did to build a focal cortical dysplasia diagnostic. Generally speaking, they work with small data sets. They build a beautiful ROC curve. They publish a paper. And that's pretty much the end of it. It sits on the research bench. And so with federated learning, with this infrastructure, we hope to advance the state of the art in translational medicine and AI. So let's just go through how this might work. MELD is actually the application that they built. It's actually in open source. So implement MELD version 1 as an edge cloud application. It can then run on every MRI imager in the world, test it globally, see how well it works. Maybe it works really well. And then finally, obviously, because you now have access in a privacy-preserving way, improve accuracy by using federated learning and create MELD versions 2, 3, and 4. So if we succeed in our mission, let me wrap it all the way back around. What difference will it make? And here I'm going to use the voice of many different clinicians in the future. And, no child will have to live with focal cortical dysplasia, endure years of seizures, ineffective, very expensive medications, or unnecessary nerve stimulators. Susan Tsai over at Phoenix Children's said if we could do this in pediatric radiology, we could actually cure kids with, these old diseases, TB and pneumonia. It's amazing. Today, a kid dies of pneumonia every 39 seconds, not because there's not treatments, but we can't diagnose it quickly and accurately enough in many places in the world, around the world. In pediatric cancer, this is kind of a sad story. There are kids who are, which is great, but many of them will die of heart disease. Oh, I see the typo, of heart disease. This is a condition called cardiac toxicity. There are researchers interested in this. If you could start to use AI to look at multiple ultrasounds over a period of time, you could diagnose that cardiac toxicity is onsetting and therefore in much earlier stage start to change their behaviors. In emergency medicine, I already told you there's a bunch of kids that arrive that don't need to be there. This is actually a sad story that happened in Texas. A kid was imaged at a spoke hospital. They thought he was a victim of child abuse. They took him to Texas Children's. He was re-x-rayed, not a really great thing, but they said, actually, this is not child abuse. And just imagine what this meant to the family and to the kids and the whole system, how much this cost. In orthopedics, we have a great relationship with Shriners Children's. This is just one thing that could be done, which is the diagnostic around hip dysplasia, which if it could be done earlier and accurately, it could avoid, as it says, a life of pain and actually what they call salvage orthopedic surgeries. And back to cardiology, my friend Charitha Reddy, Serena Barrera, who's over at Sutter Health, is a story of a little kid. I can't tell you what transposition of the great arteries is, but the kid was 1 day old and was blue, meaning not oxygen. They flew in a catheterization doctor. If we could do prenatal AI diagnostics, this could all have been realized early, reducing cost and improving outcomes for every kid in the world. So I'll end by saying, I hope those of you who are interested will join us on this mission. I often say to people, it took 40,000 people to get to the moon. We're a few shy of that in our mission. And so I invite you to become part of that. And just as a final thing to say, really pleased that Raja took an interest and became, in his own way, part of our mission, and allowed us to speak to many of you after we had our technical difficulties at his conference on data and AI. So with that, Raja, I'll turn it back over to you.
Okay. Thank you so much, Tim. So what I'm going to do here is I see some questions already coming in. So I'm going to prioritize them based on the relevance and how much time we have. So please, whichever channel you are on, we are streaming on LinkedIn, YouTube, Facebook, Twitter, and some of you are on the Zoom call. So please go ahead and ask questions, and the questions are going to be routed to me, and then I'm going to actually route them to Tim. So Tim, there is an interesting question by Stephen, and the question is, what is the I'm sort of paraphrasing it, explaining the question. So what is the longer term plan? Are you planning to build something that other companies are going to build on top of? And then I saw another question that might be relevant to this question from Prashant. How can a small diagnostic center with MRI machines, they can participate, right? So I think both questions are related. Are you building some sort of platform that other people can leverage once we do our moon landing? How can other people actually, leverage what you build?
Yeah. So to be very specific, and I will use the two words. So BevelCloud is building infrastructure. So in that sense, and many of us are from Oracle that are part of the founding team, it's like being in the database business. So, we're building infrastructure. We need applications. Our friends at Teleray are an example of that. Our friends at Died Medical are an example of that. So we're heavily a platform and wanting ISVs to participate in building new apps. So to be very clear, the Pediatric Moonshot is a phrase that we use because obviously, right, the infrastructure is useless without applications. And just like Apple had to, when they first released the phone, they had to help the creation of, or in some cases, they created, Apple Maps. Otherwise, they couldn't show people what it could do. So the Pediatric Moonshot is a phrase we use to invite many people in that either could be participating in helping design an application, in deploying and building, et cetera, because without it, in cardiology, orthopedics, et cetera, we can't, that we cannot deliver on the promise of that. So how can a small MRI? So for obvious reasons, and, in the startup business, you have to start with a focus. And so our focus has been with larger children's hospitals, but from a deployment point of view, and you just saw it with what the work we're starting to do in emergency medicine, the whole architecture does not know where it is. So we're going to put edge servers into regional hospitals that are non-children's hospitals. I already indicated that we have the technology, we can actually put it in the home. So we've not focused. We realize there are MRI imaging centers. We have not focused on those, but technologically, it's all doable in this architecture.
Okay. So thanks a lot, Tim. So there is one more question, and this is more from me. So, you mentioned this, the whole idea of federated architectures and, edge computing and all of that. And then I see some folks who have attended, they are not from cloud computing space. I mean, maybe not technologists at all. So can you give us an idea of why federated architectures and why edge computing? I mean, so just maybe in a layperson's, what would be the layperson's explanation? Why do you need federated, and why can't we do it?
So I think, and there's a whole, just to go back to a little post in Medium, there's a whole post on federated learning and consumer AI. So let me explain it this way. So, for those of you who have an iPhone, you can look at it. Siri wants to be more accurate when it listens to you. So traditional AI technique would be to take your voice when you talk to it and say, where should I go to dinner tonight or whatever, and send that voice print to the Apple Cloud. And but in doing that, in order to learn on that data, it's going to have privacy issues. Like, what else did you say to it? The second problem is, well, who's going to pay for the network bandwidth? You don't want to chew up my Verizon data plan to send it there. So Apple had to develop a technology, and Google's done this as well, to be able to learn locally. So I learn on your phone. So when Raja or Tim talks to his phone, Siri is learning on that, meaning the time I talk to it or the time Raja talked to it. Now, what it learns is what is referred to as a neural network weight, a floating point number, which it then takes, and Siri does this, and transmits that number back to the Apple Cloud, where Apple takes the knowledge from millions of cell phones, millions of Siri instances, and uses that to try to understand how to make it more accurate. So it's privacy preserving because your voice is not your voice anymore. It's just a neural network weight. And it's network preserving because it's just a bunch of numbers. It's not all of your voice print. So I hope that explains it as in a way in which people are you're using federated learning today, just to say it another way. You may not realize it.
Yeah, absolutely. And
Right.
So to once again in layperson's language, the data never leaves the premises because of the industry being so heavily regulated. So it is just the model weights that leave.
Yes.
Okay.
Yes.
And can there be any concerns around model privacy at all? Can that be a concern?
There are, in the more advanced research work, there is work on how, could you decipher from model weights? I think at this stage, it's great that the research work is ongoing. I think unlocking this for practical purposes so that we can build the type of applications in cardiology or neurology, I think this really gets us over a giant hump that everybody has, which is, I'm not letting the data leave the building. And we're saying you don't have to leave the data leaving the building. Just to make a point of it, Raja, because we may have international listeners, there's many countries in the world. We've been spending time with the guys in Norway who are saying the data is never leaving Norway. I mean, there are data sovereignty, data residency issues that are coming to the fore. Again, we're saying never has to leave Norway, but yet we all can take advantage of large, diverse data sets to build more accurate algorithms without the data ever leaving Norway.
Yeah, absolutely.
Yeah.
So I think there is a question, another question here. You mentioned collaboration. So how can independent ISPs actually, they can reach out to you? I mean, should they reach out to you?
Yeah, please reach out. I'm on LinkedIn, reach out there. We're glad to have conversations with people, show you more. We built something we call BevelCloud Studio. So yeah, please reach out.
Mm-hmm. And what sort of collaboration would you be looking for? I think that would be the first natural question.
Yeah, I mean, let's say we've kind of categorized things in two big buckets. One, amusingly, we use the word collaboration, meaning the ability to share images, whether for emergency reasons or second opinion reasons, with human clinical experts. We call that collaboration type of applications. And there's a whole host of those that are possible using this platform. Let me just interject something. Didn't want to make this presentation too complex, but not only are we twinning healthcare machines, because we had an objective to build a real-time, remember I said privacy preserving real-time. So we've done that, but we've also twinned, for those of you in the healthcare area, PACS machines, which are an offline image source. So you can now share images that are in the PACS machine with an application on the edge cloud. And the last one we have in development is digital twins for the EMR, in particular Cerner and Epic, so that if you build the application to their standards, their standard APIs, now on our edge cloud, you can deploy it globally. So you can now, with one application, access data in the Cerner application in 26 different sites that have deployed the edge cloud. So these are all, I'm just saying that's all fuel to build, next generation, I'm going to call them collaboration applications. That's one whole area. The other whole area is obviously AI. And therein, I believe what we see is it is going to have to be specialization focused. So as an ISV, you're going to say, yeah, I'm going to be very big in cardiology or neuroradiology or orthopedics or any discipline or emergency medicine. A discipline-based approach is generally what I think is going to end up happening, because without it, you don't have the domain expertise. I mean, I just used, transportation of great arteries. I don't actually know what that word means, right? But if you're going to go build that application, if you're an application developer, you better the hell know what that word means. So I think what you're going to see there is, application specific ISVs in the major areas. And so if you're in that, again, love to talk to people.
Okay, that's great. So, I noticed that most of the focus of the presentation was on radiology, right? So, and images, right? So, there's a lot of data that is in, my EMR, my doctor's notes, my prescription. So, do you plan to stick to radiology, and or is it going to be expanded beyond? And if it is only radiology, why only radiology? Why not expand to, general healthcare?
Yeah, I would say it's not radiology. We started with imaging machines. Mm-hmm. And one of the reasons why is, well, I'll just make a comment. In my opinion, EMR and EHRs are just giant billing engines. Mm-hmm. I mean, there's some information in them, but it pales in comparison to what's in the machines, meaning what's in the ultrasound, what's in the MRI, et cetera. So it's really, all of imaging machines, which people in cardiology use, ultrasound, people in neuro use, people in radiology use, et cetera. We start in imaging because the other advantage, and people in AI know this, is you're standardizing the data almost by definition, right? Doctor's notes are hard to standardize. But yes, I get an ultrasound image from everywhere. And we started in ultrasound because we started in cardiology because Anthony's a cardiologist. We also felt that ultrasound was the most difficult thing because it actually can stream data. None of the other imaging machines can do that. It's portable, which is interesting. So we figured we cracked through ultrasound, which is where we started. Then X-ray, CT, MRI, all the imaging was fairly simple, which is basically where most of the work we've done to date. What I would counsel the people to think about is, while I agree, we just said we're building EMR, EHR digital twins, it's really the other healthcare machines. So what do I mean by that? The EEG, the EKGs, the blood analyzers, the gene sequencers, the drug infusion pumps, the ventilators, the bedside monitors. We're actually working with a team in Holland on bedside monitor data to do predictions in the NICU for kids that are about to crash. So there's plenty of other data sources, to your point, which are not imaging data, but are data that is much more rich, in my opinion, than what's in the EMR and EHR. And I would just counsel people to start to think about that. I know there's a ton of work done in NLP over on the EMR side, and God bless people working on that. And I just said we're going to provide access digital twins, but I don't think that's the mother load. The mother load sits with the machines. There's just so much data coming out of them that humans have a difficult time working. So does that make sense, Raja?
It does make sense. And also perhaps, maybe the unification of the language, right? Images are maybe a language, right? Everyone understands that, right? So, I mean, and so notes in Italy, as you mentioned, I mean, a hospital there versus, and a hospital in India, the case notes might not have, the standardization, the quality that you're expecting. So I think images may have a consistent quality and the consistent language that that is understandable potentially. Right?
Yeah.
Okay, and there's a comment. I mean, it seems like there's some domain expert here, Jorg or Jorge. I don't know how to pronounce your name, but Jorg's comment is sonographists are cardiologists, not radiologists. So maybe you know something that I don't, right? So, yes, yeah.
Roger, let me just tell you, don't feel bad. I did a meeting 2 days ago with pediatric neuroradiologist, and I made the mistake of calling them pediatric neurologist. So, that just indicates the level of domain expertise I really have, at which I say to them over and over again, right? We're not trying to be the domain expert. We need you to come in and help us, right, build the applications in neuroradiology. So don't feel bad about getting this confused.
Yes, yeah, absolutely. So there is another question, since we were talking about collaboration. Once again, I will route it to you, and Tim, I will let you handle it. So question by Ellie. Is there any room for collaboration with the fintech industry, because they have been working in this, federated learning and secure multi-privacy computation applications in finance and investment, so to gain momentum? So once again,
I'll say that I did a post which was on federated learning in children's medicine. And in that post, we outlined, I think, 8 different federated learning stack providers, including several startups, that are out there. FedML is an example of that. A Flower in the UK. And if you go through that list, there are people who are working in what you just said, because this issue of privacy preservation is also going on over in the finance world as well. So I'd encourage you, and for fairly obvious reasons, I know a lot of these teams, but if you go in and you look at some of that and you go, yeah, I think we could use this, and you feel like you need an introduction, I'd be glad to do that. We obviously have spent zero time in trying to understand its applicability to that market. So, but glad to help people.
That's great. Tim, one question that is out of my curiosity, right? So when I look at this, right? So, you're talking about networking, you're talking about edge computing, you're talking about digital twins and storage and privacy, right? It is pretty much, when I look at it, it's potentially everything that has happened in cloud computing to date. Really, I mean, when I look at it, it's everything. How are you building when you're building this kind of, let's call it moonshot, right? So when you're shooting for that, how did you build your team? I mean, this is just my own curiosity, because hiring a single person who knows at least one of these areas well enough to build something, how's it going, right? So
I'll say, there's some advantages in being an old guy. I can tell you the disadvantages, but there are some advantages, which is you have a long history with a lot of people. And so, I'll just say I got lucky, meaning the core team is very diverse in its skill sets. And as you indicated, we had to be that way, and has a lot of experience in all the different areas you just discussed. And so with a relatively small team, we've been able to make, major innovations happen. We're also, frankly, operating in the world of 2022, 2023, where there's a ton of technology out there, which enables us to move much faster than it would have been 10 years ago in doing something like this. And, for those, just to make a little parenthetical comment, because we have data science people out there, the implications of ChatGPT on the world of software development, I think we have all underestimated it. I think it's pretty powerful what I think is about to happen there. We used to think that we were the last, meaning we're going to automate everybody else's job, and then will be the surviving members of this, but it may turn out to be the opposite.
Yeah.
And so, being able to use large building blocks, modern technology to do innovation in a focused way with a team which has got lots of years of experience and different pieces of domain experience functioning as a team. I'll just say we got lucky.
Okay, that's great. And that was probably my last question as well. How do you see, it's almost like an obligatory question for anything related to AI these days, right? How do you foresee possibly GPT-4, Stable Diffusion, DALL-E, and all of these actually being helpful in what you're doing?
Yeah, just to say, I've not spent any time trying to think about how ChatGPT is useful in the clinical medicine world. There's plenty of people that are talking about that. I would say and I just made the comment about it, I think what it's really going to change is how we build software. Mm-hmm. I have a friend, somebody I'm mentoring, who's building a next generation high performance database. And he's actually used ChatGPT to build the entire test suite. So, once upon a time, we would have hired QA engineers, blah, blah, blah. I mean, it's like, that's fascinating. And we're at what? We're very early in this conversation. And just to make a point of it, I think the hard part over in the world of English language ChatGPT is, well, what does language mean? Mm-hmm. That's hard. If you're generating Python or Java or whatever the hell it is, you can execute it. So its correctness is by definition correct. So that's why I go, I think none of us understand its real implications to, I'll call it our world, meaning the world of software development, infrastructure design, et cetera. I think it's just beginning.
Yeah, I find it actually hilarious now that, so back in the day, right, in late 90s, we saw that like the dot-com era, then we had the phone app era, then we had, later on everything, I saw companies pivoting to everything is going to be, machine learning or AI or smart. And now actually some of the people that I know, they are giving a generative AI angle to, every startup because that's what sells, right? So, yeah. So, so I think there is a comment by Warren Chou. So I would love to connect over LinkedIn. I'm assuming it's okay to.
Oh, please. Please. And you maybe include when you reach out, just say, hey, saw you on Data Science Dojo. That would be great.
Yes. And I think it is interesting, right? Warren is planning to build a telehealthcare solution that is tailored for a multi-country pharmacy retail chain, over 6,000 stores. Wow, Warren, it is ambitious. Yeah, awesome. So yes, feel free to connect. And as anyone who wants to connect with Tim, please mention that you attended the webinar. And, and it's always because I get a lot of LinkedIn requests, and I'm sure Tim gets a lot more than I get, right? So if you can be, I think just a tip for some of you who are younger, I mean, if you can give the context and instead of just, hey, hello, would like to connect, I think it is always helpful.
Yeah.
Okay, I think we are over time. So once again, thank you so much, Tim. Always a pleasure seeing you, right? So, and yep, thank you for taking the time.